Hey everyone, welcome to all of you. How are you all? Hope you all are doing good. So you know well what we are going to do today? Yes, we are going to solve some more numericals of thermodynamics. Okay, so shall we start? Yes. So today's first numerical, it is not numerical, it's just a conceptual question. Okay, तो हम आज का सेशन एक conceptual question से start करते हैं. This is your first question. Read from the screen. Okay, and what question says, according to this, if hot air rises, why is it cooler at the top of the mountain than near sea level? Okay, that means if the air which is rising upward is hot, why it becomes cooler when it reaches at the top of the mountain? We know that, students, hot air is light in weight. Okay, so it just start to raise up. Okay, but when it reaches at the top, why we find always a cooler air? So you need to give the reason. Cool air present at the top of the mountain. So what we will give the reason, because we know that with the height pressure decreases. As height increases, pressure decreases. Okay, and when the pressure decreases, what will happen? Gas will expand. The air which is going up, and you can say the air which is at height, it will expand. Okay, and when it will expand, what will happen, students? Obviously temperature will decrease. Okay, in another way you can say that if pressure decreases, okay, with the height, then it is a kind of adiabatic process. Okay, there is a expansion of gas. ओके जैसे ही आपका प्रेशर डिक्रीज हो रहा है, डिक्रीज होते होते क्या हो रहा होगा, उसका वॉल्यूम बढ़ रहा होगा. तो वॉल्यूम की वजह से ये जो एक्सपेंशन है, ये कैसा एक्सपेंशन होगा? एडियाबैटिक एक्सपेंशन होगा स्टूडेंट्स. एंड वी नो दैट इन एडियाबैटिक एक्सपेंशन dq इज इक्वल टू 0. ओके, सो total energy 0, that means du will be minus dw. So you can say internal energy also decreases because of the adiabatic expansion, and when internal energy decreases, temperature decreases. So are you getting the meaning? I mean reason behind it. इसका reason क्या है? When hot air rises, because of the height, pressure also decreases, but because of the pressure decreasing, gas is going to expand. Okay, and this expansion of gas is adiabatic expansion, which implies that internal energy decreases, okay, at the height. That's why your temperature is very low at the height, at the top of the mountain. Okay, so this is your first question. So let's take another one question also, that is of conceptual question. Okay, this one is also conceptual question. So this is your question. Read it carefully and try to find out the reason. Yes, so what is this question? Suppose a body spends its mechanical energy to overcome friction. Will it be a reversible process? Will it be a reversible process? Consider this is an object. Okay, this is an object, and this object is moving. It is in motion, and it is kept on surface, because we are talking about friction, so consider the surface. Now when this object is in motion, we are considering that it is expending its energy to overcome the friction. In overcome the friction, अब ये move कर रहा है, इसको इसके पास friction है, तो इससे इसको ओवरकम होना है, तो कुछ एनर्जी है क्या कर रही है, उसमें एक्सपेंड कर रही है. एंड कंसीडर दिस इज रीचिंग एट अनदर पॉइंट फ्रॉम ए टू बी. ओके, सो इज दिस प्रोसेस अ रिवर्सिबल प्रोसेस? So you will say, what is reversible process, students? Reversible process means a process which can be retraced in opposite direction on the same path. Okay, that means अगर किसी प्रोसेस को आप रिट्रेस कर सकते हो उसी पाथ पे अपोजिट डायरेक्शन में विदाउट एनी चेंज then that kind of process is known as reversible process. Okay, so let's check. अगर मान लो ये ऑब्जेक्ट यहाँ से यहाँ पहुँचा, कैन यू bring it back without any change? Yes, we can bring it back. Okay, but what about the loss in friction? That will also happen in this case. Okay, means friction is also going in forward path as well as in reverse path. इसका मतलब क्या हुआ कि दोनों ही डायरेक्शन में फ्रिक्शन एक्सपेंड हो रहा है. यू कैन नॉट रिकवर द एनर्जी विच हैज एक्सपेंड इन फ्रिक्शन. दैट मीन्स वी आर नॉट ट्रेसिंग आउट द एग्जैक्ट प्रोसेस. एग्जैक्ट प्रोसेस का मतलब जितनी एनर्जी यहाँ पे थी उतनी एनर्जी वापस मिल जानी चाहिए आप इस ऑब्जेक्ट को अगर बैक लेके आते हो ए पॉइंट पे. तो ऐसा तो नहीं होगा. वाई? बिकॉज व्हेन वी आर टेकिंग दिस ऑब्जेक्ट ऑन द सेम पाथ it will expend more energy into overcome the friction. Okay, तो एनर्जी जो एक्सपेंड होगा वो तो इंक्रीज ही होगा, उल्टा आप उससे रिकवर नहीं हो पाओगे. ठीक है, तो ये इस तरह की प्रोसेस जो है वो रिवर्सिबल प्रोसेस नहीं है. रिवर्सिबल प्रोसेस नहीं है. आर यू गेटिंग द मीनिंग एंड रीजन बिहाइंड इट? तो आपको बस ये चेक करना है कि अगर कोई प्रोसेस को आप एज इट इज रिपीट कर सको ऑन द सेम पाथ इन अपोजिट डायरेक्शन, दैट काइंड ऑफ प्रोसेस इज रिवर्सिबल, अदरवाइज दैट इज नॉट. एंड विदाउट एनी चेंज मीन्स योर एनर्जी शुड ऑल्सो बी कंजर्व ऑन द सेम प्रोसेस. ओके, तो यहाँ पे तो एनर्जी कंजर्व नहीं है, दैट्स वाई इट इज नॉट अ रिवर्सिबल प्रोसेस. नाउ लेट्स मूव टू नेक्स्ट क्वेश्चन. होप दिस इज क्लियर टू यू. सो दिस काइंड ऑफ कॉन्सेप्चुअल क्वेश्चन कैन ऑल्सो बी आस्क इन योर एग्जाम. आते भी हैं इस तरह के क्वेश्चंस, आपको पता है. ओके, सो लेट्स स्टार्ट न्यू वन क्वेश्चन एंड दिस क्वेश्चन इज, यस, दिस इज अ न्यूमेरिकल. ओके, रीड योर क्वेश्चन केयरफुली ऑन द स्क्रीन. व्हेन अ monoatomic gas expands at constant pressure, the percentage of heat supplied that increases the thermal energy of the gas and that which is involved in expansion. Means एक मोनोएटॉमिक गैस है जो कि कांस्टेंट प्रेशर पे क्या हो रहा है, एक्सपेंड हो रहा है, एंड द परसेंटेज ऑफ हीट सप्लाइड दैट इंक्रीजेज द थर्मल एनर्जी. Percentage of heat supplied that increases the thermal energy. Yes students, we have done similar kind of question earlier also. Means consider this is heat supplied, we know that. Okay, and how much energy out of this is used in increasing the temperature, Cbdt. यही होता है आपका फ्रैक्शन ऑफ एनर्जी यूज्ड. ओके, तो यही चीज़ें हैं हमारे को जो इसमें कैलकुलेट करनी है. इसको हम पहले हम फ्रैक्शन निकाल लेते हैं कि कितना जो पार्ट है एनर्जी का कितना यूज़ कर रहे हैं हम टेम्परेचर को इंक्रीज करने में. ठीक है, एंड एज यू गेट दैट पोर्शन जस्ट कैलकुलेट द परसेंटेज, दैट विल बी वेरी इजी. सो देयर इज मोनो एटॉमिक गैस, वी आर टॉकिंग अबाउट मोनो एटॉमिक गैस. ओके, सो फॉर मोनो एटॉमिक वी नो दैट degree of freedom F is 3. So Cvdt will be what students? 3 dt. Okay, 3 by 2 dt because Cv is F by 2. Cv is F by 2 R. You can say Cv 3 by 2 R dt. And Cp is what students? We know that it is changed by Cv by one amount. Okay, so take it plus. So 1 plus F by 2, we know the formula, 1 plus F by 2 for Cp. Okay, so 1 plus 3 by 2 R. Okay, and this is R dt, Cp dt. Okay, so this will be what? You can see 3 by 2 divided by 5 by 2. Okay, all the constants that will be cancelled out. Okay, how much this? 3 by 2 multiplied 2 by 5, it is 3 by 5, means 3 by part. This is the fraction. How to be converted into percentage? मतलब हमारे को 100 के रेस्पेक्ट में देखना है तो हम क्या करेंगे, इसका 100 से मल्टीप्लाई कर देंगे. दिस विल बी 20, so 60%. So 60% of the gas is used in raising the temperature, okay, out of 100%. Then 40% gas is involved in the expansion. यही होगा कि भाई बचा जितना 60% तो किस में यूज हो गया, टेम्परेचर को इंक्रीज करने में. बचा हुआ जो पार्ट है इसका, दैट पोर्शन इज यूटिलाइज्ड इन द एक्सपेंशन ऑफ गैस. So 60% and 40%. This is the option number 3 is your answer, option number C. Okay, hope you all are clear with this. We have done exact similar kind of question in previous class, so I think this is not, this should not be much bother with us. Okay, yes. Yes, so this is your next question. Graph is given to you, A, B, C, D, 4 curves are given to you in PV graph. Okay, and what is asked in this question? A given amount of gas, the curve which represent adiabatic and isothermal changes are. Okay, you need to identify which curves are showing adiabatic expansion and isothermal expansion. Okay, so graph is PV graph. A and B, first is your A and B. This is a point, this is curve A, this is curve B, and this is C, and this is D. So students, what is the graph, what kind of graph form in adiabatic expansion? We know that for adiabatic expansion and for isothermal expansion, what kind of relation, दोनों के चेंजेस में एक रिलेशन होता है. क्या होता है अगर हम ग्राफ की बात करें? एडियाबेटिक एक्सपेंशन ग्राफ इज मोर स्टीपर देन isothermal graph. Steeper means more sharp. Okay, so adiabatic slope, you can say slope, and adiabatic change. Adiabatic change is showing what? Slope of PV versus graph. Okay, so adiabatic change is gamma time isothermal change. Okay, so we just need to observe which two curves are related as one is like this is B, so we can say A is more steeper than B. We can see this thing, and in this case, and if individually you see the graph, then this is the graph of isothermal and this is the graph of adiabatic. Isothermal is not that much. Okay, adiabatic is, and graph we are talking about PV. PV ग्राफ ऐसा ही बनता है. आइसोथर्मल एंड एडियाबेटिक दोनों का इंडिविजुअली मैं आपको बता देती हूँ. ये इंडिविजुअली ग्राफ है. ओके, एंड दोनों में डिफरेंस क्या होता है, कैसे आप पहचानोगे अगर दोनों की, क्योंकि शेप तो एक जैसी सी होती है, ठीक है, डिक्रीजिंग ऑर्डर में होता है. इस तरह से स्लोप नेगेटिव होता है, बट स्लोप नेगेटिव के लिए हम यहाँ पे नेगेटिव साइन भी लगा सकते हैं, ठीक है. बट एडियाबेटिक कर्व is more steeper than more steeper than isothermal curve. So we can see this A is more steeper than B. That means A is for adiabatic and B is for isothermal. Okay, B is for isothermal. So you just need to identify. ये तो बहुत easy था. I know you can do this by yourself also. So let's move to next question. Yes, so your next question is shall we take a numerical? Okay, let's take a numerical this time. This is also a very easy numerical. You can do it by yourself. Just check out the question from the board. A gas is compressed at constant pressure of 50 Newton per meter square. What is given, students? 50 Newton per meter square means pressure. We can see the unit 50 Newton per meter square. Force per unit area. Pressure is given to you. Okay. Then there is change in volume 10 meter cube to 4 meter cube. ओके, दैट मीन्स एक्सपेंशन, पहले वॉल्यूम कम था, बढ़ चुका है, एक्सपेंशन हो रहा है, तो V1 तो आपका हो गया, कितना हो गया आपका V1, 10 मीटर क्यूब टू 4 मीटर क्यूब, इट इज कंप्रेशन। जब भी वॉल्यूम कम हो रहा हो दैट इज कंप्रेशन, इफ वॉल्यूम इज इंक्रीजिंग दैट इज expansion. Okay, so this is 4 meter cube. Okay, we can say this is a compression. Next, what is this? Energy of 100 joule is added to this, means how much energy is added, 100 joule. Okay, you can say Q, dq, delta Q, anything. Okay, इतनी एनर्जी उसको ऐड की है. Then find out the internal energy. What would be internal energy? We know the relation. इंटरनल एनर्जी एंड डी क्यू में क्या रिलेशन है, डेल्टा क्यू इज इक्वल टू टोटल एनर्जी रिमेन कंजर्व, सो डेल्टा क्यू इज इक्वल टू डेल्टा यू प्लस डेल्टा डब्ल्यू. ओके, एंड डेल्टा यू विल बी व्हाट, it is delta q minus delta w. Delta q is given to you, it is 100 minus delta w will be what, students? P, and delta v is given to you. We know that w is equal to p delta v. So P is, this is your work done formula, P delta V, pressure multiply change in volume. Okay, so just simply use this directly here. P is 50 Newton. Okay, and this will be what, 10 minus 4. Okay, 10 minus 4. Actually it is final minus initial, so take it as 4 minus 10. Okay, now this answer will come in negative form, so this 4 minus 60 will 4 minus 10 is minus 6, minus 6 multiplied by 5 is minus 300, and this minus will be plus 300 joule. Okay, so total internal energy is what, students? It is 400 joule. Okay, so we can calculate like this. सबसे पहले आप देख लो आपको क्या क्या गिवन है, इसमें तो कुछ सोचना ही नहीं था, डायरेक्ट फॉर्मूला बेस्ड क्वेश्चन है, एनीवन कैन डू दिस. सो लेट्स मूव टू नेक्स्ट क्वेश्चन. Yes, so shall we take numerical? Yes. So this is your next question. In this question, what is given to you? Cp and Cv ratio for a gas mixture consisting of a 4 gram helium and 32 gram of oxygen. You need to find out Cp and Cv ratio, Cp by Cv. Okay, and what is given to you? There is a mixture we are using, mixture of gas helium, that is 4 gram helium plus 32 gram of oxygen. Okay, so we this is a mixture. अब क्या करना है, Cp by Cv means first we need to calculate Cp, then Cv, and we will just simply divide it. We know that, students, helium is monoatomic gas, oxygen is diatomic gas. Okay, so 4 gram of helium means 1 mole of helium. Okay, 4 gram of helium is 1 mole of helium, and similarly 32 gram, it is what, 32 gram, we know that for oxygen it is equal to 1 mole. So we can say 1 mole we are taking of helium and oxygen respectively, and just making by combining them we are taking a mixture of them. Okay, so next simply just find out Cv. What will be Cv? We know that F by 2 formula. Okay, when number of mole is present then N1 we multiply. Okay, so it will be what, N1 means 1 mole multiplied by helium. Helium is monoatomic, that is 3 by 2R, plus for this oxygen it is diatomic, so 5 by 2R, this is also 1 mole. Okay, solve this, 3 by 2 plus 5 by 2, it is 4. Okay, and 4R you can say, and Cp will be what, this is for monoatomic, this is diatomic. For monoatomic Cp is how much, just you can say 1 plus 3 by 2 means 5 by 2, so 5 by 2R plus For diatomic it is 7 by 2, 1 plus 5 by 2, 7 by 2r. Okay, so it is 7 by 2r. Now 5 by 2r plus 7 by 2r, it will be what? 6r. Okay, and simply Cp by Cv or Cv by Cp. For Cv by Cp, just check, it will be 2 by 3, but in the question they are asking for Cp by Cv, so this will be 3 by 2. This is your answer. Okay, 3 by 2. So check the options. 3 by 2 means 1.5. 1.5, option number C. This is given to you. Okay, so again we are repeating such kind of question we have already done, in which you need to calculate Cp and Cv. So you just need to be careful with monoatomic and diatomic, and with their degree of freedom, how do we calculate Cp, how do we calculate Cv, then whatever the relation you need to calculate, just put in the value and find out the answer. Okay, in the same consequence, another question is in front of you. Just read it carefully. What is given in this question, students? It is given that percentage change in volume means delta V upon V. Percentage change in volume, okay, during an adiabatic expansion. Okay, it is given to you 5%. Okay, or you can say if we are talking about percentage change, then 5. Okay, this is given to you. Then find out percentage change in pressure for an adiabatic process. If in an adiabatic process percentage change in volume is this, then calculate the percentage change in pressure. How do we calculate? Whenever we talk about adiabatic process and we are relating pressure with volume, we use the equation of adiabatic process, which is PV gamma is equal to constant. PV to the power gamma is equal to constant. Okay, but we want change, and for the change what we do, students, we take differentiation both side. Okay, so simply just differentiate. Okay, this will be, there are two variables, so we will differentiate 2 times. First keep P as constant, then gamma V, gamma minus 1 plus, and for V it is delta V. Okay, with respect to volume we are differentiating. Now differentiate with respect to pressure. Okay, so it will be what? V to the power gamma as it is, and P, it is delta P. Differentiation of P is delta P. Okay, and this is constant, so this side 0. Now if we take that side, we will just separate the pressure and volume, then take volume this side. This will be what, students? Delta V upon V to the power gamma. Gamma V to the power gamma minus 1 is already present. Okay, and take this pressure that side. Okay, and this is negative because this is plus, that will go that side, it will be negative, and delta P upon P. Okay, so we are getting this. Now you can check V to the power gamma is cancelled. Okay, and after solving this, what we are getting? Gamma delta V upon V is equal to minus delta P upon P. Okay, no problem in this calculation. Just yes, do your calculation very carefully. Okay, we can see V to the power gamma in numerator as well as in denominator, so they will cancel. Only V inverse gamma will left, so gamma is there and V inverse means delta V upon V it forms. Okay, so this, and what we want? Delta P upon P. Okay, and we want in percentage form, so just simply multiply by both, multiply by 100 both sides. So we know the value of this, how much? It is 5, and this value we need to calculate. Okay, take negative sign if you want. Negative is you can say it not matter here. Okay, yes, negative means increase and decrease, you can say. So this will be a change in delta P upon P, multiply by 100. That means multiply with gamma value to the change in volume. And how much gamma value is given to you? It is given to you 1.4. Okay, this is given gamma value 1.4. So 1.4 multiplied by 5. This will be 7%. And this negative sign means decrease. If pressure volume is this, then your pressure will decrease 7% time. Okay. So this is your question. Simply what we are doing, we are using the adiabatic equation, and simple, it is given to you. You just use this to find out the change in pressure. Hope you are clear with this, and you will do also by yourself. Okay. So try it by yourself also. Let's move to next. So in the same series, your next question is this. Read this carefully, then we will start. Yes. So take what is given in this question, students. It is given that gamma value 7/5. Okay. And change a gas is changing, diatomic gas is changing adiabatically from PD to P dash D dash, where D is density. Okay, D stand for density. Now you need to calculate the value of P by P dash if D by D dash is 32. Okay. So value of P by P dash if D by D dash is 32. It is, are you getting something with this question? A diatomic gas is there, okay, and adiabatic, because gamma is given, that means we are talking about an adiabatic process, okay, and in that gas is going through a process in which change in pressure and density is going in such a way that PD changing to P dash D dash, okay. And another given information is D by D dash is 32. So what would be P by P dash value? So students, if we talk about adiabatic equation in case of pressure and volume, that is PV constant. Okay, PV gamma is equal to constant. But this is not is a relation between pressure and density. Okay, relation we know that is between pressure and volume, but you can convert it into pressure and density also. How? Because we know that volume is inversely proportional to the density. Okay, because density is mass per unit volume. You can see for constant mass it is volume and density are inversely proportional to each other. So for V we can put 1 by D, and for V dash we can put 1 by D dash. Okay, so now your equation becomes like this. P1 V1 gamma is equals to P2 V2 gamma. This is adiabatic equation that we know. Okay, now we also know that at the place of volume we can put 1 by density. Okay, so just put P1, this will be P1 D1, that means this is 1 by D at the place of volume, 1 by D1. Gamma is equal to P2 1 by D2. Okay, 1 by D2 gamma. Yes, in your question it is not D1 D2 D and D dash, anything you can do. Okay, I am taking D1 and D2. Okay, so this is P1 and 1 upon D1. This is also given that D upon D dash means D1 upon D2 is 32. Okay, so first make it separate. This will be what, students? P1 upon P2. Take P2 this side, and that 1 upon D1 will go that side. It will become D2 upon D1. Okay, yes, P1 upon P2, this will go that side. Sorry, it is D1 upon D2, because pressure is inversely proportional to volume and volume is inversely proportional to density. That means pressure is directly proportional to density. Okay, so and take gamma as it is. Okay, so now we have this and we want to calculate this. We have also the value of D1 and D2. So D1 and D2 value is given to you, that is 32. d by d dash और d1 upon d2 32 to the power gamma. Gamma is 7 by 5 and it is also given to you 32 to the power gamma by 7 to the power, this is not given to you. Okay, you will just calculate it, otherwise leave it in this form. P1 upon P2 is 32 to the power 7 by 5. Okay, you can also calculate it by using calculator, but without calculator ये आपके लिए difficult होगा, इसलिए better होगा अगर आपके options इसी form में दे रखे हैं. एंड यस हमारे ऑप्शंस इसी फॉर्म में है तो हम इसको ऐसे ही रहने देते हैं. ठीक है, सो दिस इज योर द रेशियो ऑफ P1 एंड P2. ओके, यस, सो आई थिंक नो प्रॉब्लम इन दिस क्वेश्चन. थोड़ा सा एक हल्का सा आपको ट्विस्ट किया है इस क्वेश्चन में कि वॉल्यूम ना देके डेंसिटी दी है, तो इतने कॉन्सेप्ट तो हमारे क्लियर है ही कि हम वॉल्यूम की जगह क्या पुट कर दें, इनवर्स ऑफ डेंसिटी. ओके, सो लेट्स मूव टू नेक्स्ट.